All right, so we're looking at our last lesson here, solving problems using acute triangles. So really we're looking at cosine law versus sine law. So we talked about both of them before. Pretty much you're going to use the sine law when you have an angle and an opposite side. That's when we use the sine law. And then the cosine law we use when we have three sides or two sides and a contained angle, so like the angle in between. So this lesson you're going to be going back and forth, and then we're going to get into some word problems too. All right, so first one, what do you think, sine law or cosine law? We have an angle and an opposite side, so we're going to use the sine law. So I have sine 58 over 45 equals, I'm looking for side A, which is opposite to this angle here. I don't really have that angle, but I can find the other angle. So that other angle, I'm just going to call it angle X, is opposite to 48. And then I can cross multiply, and divide, right? And then I'll go second function. And I get angle X is 64.767 degrees. So I'll just really quickly show you that again on your calculator. So we're going sine 58, close the bracket, cross multiply to 48, divided by 45. We get a decimal. We go second function sine, second answer, and that's where that 64.76 is coming from. All right. So now that I have that angle, I can find the other angle by going 180 minus 58 minus 64.767. So I'm going to go 3 or 4 decimal places. We don't want to round too early. And I get 57.23 degrees for that angle. Notice how that is opposite to side length A. So I will use that angle to help me find side length A. So I have sine 57.23 degrees over side length A, and then I'm going to use that pairing that I originally had, which was 58 over 45. And then we will cross multiply and divide. So we're going to cross multiply, divide, and our final answer, we should be getting 44.6 centimeters. Great. Moving on. So I have two sides and the contained angle, so I'm going to be using sine law. So when we write this out, we have x squared equals 15 squared plus 19 squared minus 2 bracket 15, 19. And remember, we talked about this in the cosine lesson. For your a and b value, it doesn't matter which one you put first and which one you put second. And then I have cos 26. Now I'm going to go to my calculator and I'm going to type this all in. 15 squared plus 19 squared minus 2 bracket 15, 19, cos 26, enter, second function cos square root, second answer, and we get 8.6 if we round. Okay. Next up, we're talking about angle of elevation and depression. So an angle of elevation is between, if you drew a straight line and you elevated up from that straight line, right? So if I draw a straight line and I go upwards, that is an angle of elevation because I'm elevating up. And you can elevate up from either side of that straight line. Angle of depression is when we elevate down. So we have a straight line and we're going down. So now really quickly, out of these angles on the left-hand side, can you identify which are angles of elevation and depression? So this first one, I have my straight line, I'm going down, so that would be depression. Over here for B, I have a straight line and I'm going up, that's elevation. Straight line going down, that's depression. Straight line going down, depression again. Depression again, and then over here we have elevation because we're elevating up, and then we're elevating up, elevation. Great. A boat heads east 8 kilometers. So here's where we start, and then we're going east 8 kilometers. I might draw that up a little higher actually. East 8 kilometers. Remember, you got your north, south, east, west. Those are your directions. Okay, at the same time, another boat travels south towards east 50 degrees. So south would be this way, east from the south is 50 degrees. From the starting point 4 kilometers away. So 4 kilometers away. All right, so here's my first boat, boom. Here's my second boat, boom. How far apart away are the boats? So this is what I'm looking for. So right now, if this is 50 degrees, this inside would be 40 degrees because that whole line, like that whole right angle, should add up to 90. So if this is 50, I know that's 40. Now I'm going to use the cosine law, right? Because we have two sides and a contained angle. So I'm going to go c squared equals 8 squared plus 4 squared minus 2 bracket 8, 4 cos 40. If you type that in your calculator, you'd get 30.97316. And then if we just square root, we get an answer of 5.6 kilometers. Example 3. So Albert and Ella are standing 670 meters away from each other. So let's draw Albert. Ella. And they're 670 meters away from each other. Albert measures an angle of elevation of 37 degrees towards an airplane. There's my airplane. And Ella measures an angle of 65 degrees towards that same airplane. How high is that airplane? Okay, so right now we have this angle here we can find, right? Because do you see the big triangle in black? I know it has to add up to 180, so I can go 180 minus 37 minus 65, and I get 78 degrees. So I got 78 degrees here, right? And then I could find either side. I think I'm gonna find this side over here and call it x. And then if I have x, that will help me find the height. So let's go ahead and set that up. So we're going to use the sine law because we have a sine side, 670 is opposite to that 78 degrees. And then 65 degrees is opposite to side length x. So then I'm going to cross multiply and divide, and I should get 620.792. And we're going to make sure we don't round too early, so you can see I went 3 decimal places, and I'm going to draw that in the diagram. Now from here, let's just focus on this part of the triangle to help us find the height. So this would be a right triangle, right? Because it should be directly straight up. Where's the height? That's what we're looking for. So that would be a 90-degree angle. So that 90-degree angle is opposite to the 620. So let's go ahead and write that down. And I'm looking for the height, which is opposite to the 37 degrees. And you could have used like your SOHCAHTOA too. I'm just going to use the sine law because I actually think it's a little faster. I like it a bit better. But if you use SOHCAHTOA in this case, you could because that's a right triangle. All the other problems you wouldn't be able to because you can only use SOHCAHTOA for right triangles. But I'm just going to use the sine law. Okay, and then again, we're going to cross multiply and divide. If we type that in our calculator, we should get 373.6 meters. All right, Robert is in a helicopter 85 meters above the ground. So let's draw that out. So 85 meters above the ground is my helicopter. And he sees hikers on the same path as a grizzly bear. So here's my hikers, boom. And here's my grizzly bear. Yikes. Okay, so the angle of depression to the grizzly bear. So remember, the depression, you have to draw horizontal, and then the angle of depression would be 65 degrees. And then the angle of depression to the hikers, right, you got to draw that horizontal, and then it would be 30 degrees. So from here, if this is 85 meters, this would be 85 meters. I'm looking for the distance. So I'm looking for this distance here, and I'm going to call this y, this distance here. So we're going to do each one. I'm going to do the one over here first. So I have sine 30 is opposite to that 85 equals, and I know this is a 90-degree angle, right? So that means this angle would have to be 60. 60 is opposite to the y, so I'm going to go sine 60 over y, cross multiply and divide, and you should get 147.2243. Let's go ahead and draw that in the diagram. Okay, and then over here we'd have sine 65 over 85. If this is 65, this over here would have to be 25. Can cross multiply and divide. And then I get 39.63615. And then I add those together, and if I add them together, I get 187 meters. Great, okay. Moving on, 2 airplanes leave Calgary Airport at the same time. Ooh, this is a trickier one. The first travels 390 kilometers an hour, while the second travels 415 kilometers an hour. So after 3 hours, they're 1,500 apart. So we need to figure how far each travels. So we're gonna go 390 times 3, and that gives us 1170 kilometers. Then we're gonna go 415 times 3, and that gives us 1245 kilometers. Now we're going to go ahead and draw this picture. So one airplane goes one direction, the other goes the other direction. We know they end up being 1,500 kilometers apart. One of them travels 1170 kilometers. The other travels 1245 kilometers from that starting place. So now it says determine the angle between their paths. So this is the angle I'm finding. I'm going to need to use the cosine law because I have 3 sides. So 1,500 is opposite to the angle I'm trying to find, so it has to be that c squared. So I have 1,500 squared equals 1170 squared plus 1245 squared minus 2, 1170, 1245 cos c. Now I'm going to type this in my calculator. 1,500 squared. That gives me a really big number. 225, and then I have 1, 2, 3, 4 zeros when I type that in. And then I'm going to go 1170 plus 1245 squared. Let's type that in. Plus 1245. Oh, I put 1175 instead. Oops. That gives me 2918925. $2918925, And then 2 times 1170 times 1245 gives me 2913300 cos A. So now I'm going to subtract that 2918925 over. And that gives me negative 668925 equals negative 2913300 cos A. And then I can divide. So then I get cos A equals, I'm actually going to type that in my calculator. Let's type that in. Negative 668925 divided by negative 2913300. And then we're going to go second function cos, second answer, and we get 77 degrees if we round to the nearest whole. So I'm getting 77 degrees. Woo. Okay. A bicycle leaves the house and heads south for 3.8 kilometers. So here's my bicycle. It's going south. Okay, at the same time, another bicycle leaves the house and travels southwest 60 degrees for 4.8 kilometers. Okay, how far are the two bicycles? So again, we're going to use cosine law because that would be two sides in the contained angle. So I have c squared equals 4.8 squared plus 3.8 squared minus 2 bracket 4.8 3.8 cos 60. Type that in my calculator. Don't forget to square root and you should get 4.4 kilometers. All right, last one, determine the perimeter. So we want to find this right here. In order to find that, notice how this is an isosceles triangle. I'm going to need the angle. So this is a regular hexagon, which means it would form triangles that are all equal to each other, and there's 6 triangles, right? A circle is 360 degrees. So if I just want this section of the circle, I want just 1/6 of it. So what I'm going to do is I'm going to take that 360 degrees and I'm going to divide it by 6, and that gives me 60 degrees. Okay, and that 60 degrees will help me find the side length because now I see, hey, I'm going to use the cosine law. So I'm going to go c squared equals 5 squared plus 5 squared minus 2 bracket 5 cos 60. If you type that all in, you end up getting 25, and then if we square root that, we get 5 meters. So we want the perimeter all the way around, so we're just going to times that by 6 because there's 6 triangles all the way around, and we should get 30 meters in total.